Now let's talk about the different combinations of the resistors, which is number one, resistors in parallel, and the second combination is the series combination of the resistors. Now first consider two resistors R1 and R2, which are connected in parallel to each other between 2 points A and B. Let there be a source of voltage V connected across this series combination of R1 and R2. Now since this voltage source is connected across this combination, so here you can see that the left arms are the left terminals of both R1 and R2 are connected to the positive terminal, and similarly the right hand terminals, our right side terminals, are connected to the negative terminal of the battery. So the same voltage V is appearing across R1 and R2. Now the current provided by the source is I, and I is obviously not the same in both the resistors, because at this point the current I will divide into I1, which will go through R1, and I2, which will go through R2, and then here the two currents will recombine, and then it will enter the seat of EMF at its negative terminal. So the voltage is the same, but the current is different, and the voltage across the resistor R1 is obviously I1 R1, and here it will be I2 R2. So the current over here will be the sum of I1 and I2, and if we substitute the values of I1 and I2 in this equation, and this can be done as I1 R1 is equal to V. So I1 will be equal to V divided by R1, and I2 will be equal to V divided by R2, and since this total voltage V is causing the current I in this parallel combination of the resistors, so if this parallel combination is to be replaced by some equivalent resistance R equivalent, then the current in that equivalent resistance would be V divided by R equivalent. That would give you the total current I. So substituting the values of I, I1, I2 in this equation, we get this type of equation, and since V is common on both sides, we can cancel it out, and we will be left with 1 over R equivalent over here, 1 over R1 over here, and 1 over R2 over here. So taking the LCM as the product, we will get R2 plus R1 in the numerator, and R1 R2 the product in the denominator. So if we are to obtain the value of R equivalent, we will reciprocate this equation. R equivalent will be equal to this product. Since we have reciprocated the left hand side, we will also reciprocate the right hand side.